Hello, and thanks for joining me again today. I'll be working on drakon render again. For those of you who watched the last session, I discovered a problem with the layout algorithm, what I thought was a layout algorithm. And the plan for today is going to be to work on that problem and maybe try to resolve it. I invested some time off camera looking into why that real life diagram might be rendered incorrectly, and I have my ideas. We'll be exploring them today, so I hope you have your beverage of choice, and let's dive into the code. So here's the output that I produced off camera of various other diagrams to check the correctness of those two functions that we use, position icons and the function that reduces the dependency plane. And what I did find out is that the cause of the problem indicated here, let me just drag it here. The problem that is manifesting in this issue might not be caused by the function that reduces the dependency plane or the function that positions icons from the dependency plane, but rather by the initial function that removes duplicates from the input code. Not to say that there are duplicates in the list of icons provided in the input, but if you go down the dependency tree and you try to build the dependency plane, that process will introduce duplicates that at this stage I think are unavoidable, and you need to clean them up before trying to position icons, reduce dependency plane, position icons, reduce dependency plane, and so on and so on. So what I'm blaming at this moment for the incorrectness of this diagram is the function that removes duplicates, and I would like to invest some time today into working on it. Stick with me. So this is the infamous function, and from the very start it is already kind of tricky to reason about what it's actually doing. So there are two problems that we need to fix. So first is remove duplicates seems to be scanning the dependency plane from the bottom to the top. You can see that we apply the reverse function on the collection of icons before we remove duplicates. I think this is incorrect. I have done a number of exercises on paper to prove that we might be better off just removing duplicates from a dependency plane that's just sorted in a normal human-friendly way, top to bottom. So let's try to write a function that does exactly that now. Oops. And for the names not to clash, we're going to use a slightly modified name. So this function, I believe we should be able to use new unique icons. We fold a single row to find icons that are not an element of unique icons. And if we do find them, we just add them to the accelerator. It's very cold today. So all we have to do is just recursively go through the list and remove duplicates. I'm not sure if it's that cold or if it's just me sitting all day by the computer. Yeah, let's try this and let's see what happens. There is going to be one unintended side effect that we will have to address shortly, and it is going to be the fact that the end icon might not be rendered at the very bottom of the diagram, but I think I have an idea how to resolve this. Let's just check which diagram will be producing. Just drakon diagram. So the diagram we know well at this stage, it's the currently the flagship diagram in the repository, will change. Namely, this end icon will be moved initially somewhere here, but ultimately I want to push it all the way down here, but in column 2, not in column 1. Oh yeah, of course. I started executing the layout algorithm step by step. Therefore, I'm only positioning icons like this. But now I think we can call it recursively. All right, what do we have here? It looks like it's just reversed. That is also not what I wanted to see. All right. In that case, let's revert to the function that only renders the first column of the dependency plane, and let's print all dependents and also the dependency plane, which we already have. Let's give it some more clarity. And in this file, I already have the dependency plane that we start with. Sorry, all dependents. So here we'll be placing the dependency plane. Oops. Oh, this is interesting. And if I was to find my notepad. I took it somewhere. This is the image that I produced in my notepad. We should be starting with title 0. And the graph should look like this, ideally. What I'm not getting is why... Yeah, 0 is first. But the rest is... this doesn't look right. The rest seems to be inverted or reversed. Okay. So again, reminder, this part of the file is all dependents. This part of the file is all dependents where we have the duplicates removed. So we start with 5a. That depends on the 8. Sorry, yeah, that has one dependent, and it is the icon 8, aka the end. So 8 used to be here, because it looks like sort of a mirror image of what we would get from the list of all dependents, which is not bad. So in the next row, we're expecting, 5a, action A1, and that's it, I think. Yes. In the next row, let's see what we can expect. Action 5, action A, action B. You know what, actually, what would be cool if we could have these two side by side. So action 5, action A, action B. Action A and action B. So far it's looking great. But there's only also one more thing. And we also have icon 8, which I believe would be correct, because icon 8 is a dependency of question 5 prime. We can see this here. Well, it's not a dependency of 5 prime, it's a dependent of 5 prime. Perfect. So technically, if we hadn't moved the end at the very bottom of the graph, it would be placed somewhere here at this level, together with action 5, action A, action B. So what we're getting here is by all means correct. And the row should end here, and it does. Next row should contain question 5 prime, question 6, and address 9. 5 prime, correct. Now we're expecting have 6 and 9. 6, correct. Correct. Next, we're expecting 3 and 4. So what we're doing right now is I'm proving that the removal of duplicates works in the new way, meaning scanning not from the bottom of the dependency plane to top, but from the top to its bottom. 3, 4, correct. So in the next row, it will be easier. Question 2, headline 1, and title 0. 2, correct. 1, correct. And 0, correct. All right, so now the only thing I need to do before feeding this dependency plane to the function that positions icons, well, actually 2 things. One is I can't have things like that. If row is empty, just don't add it. And 2, I need to reverse it. Okay. Sorry about that. I'm getting a phone call. I'm back now. Sorry. But I used this time to make myself some tea, and I'm a bit warmer now. So let's go back to the code. Where were we? Oh, I think we proved that the removal of duplicates works. We just need to reverse the results and also remove any empty rows that could be formulated. Let's do that. Let's do it like this. Here. Yeah, here we reverse every dependency plane. We'll have to do the same here. So now we're getting a diagram like this. 1, 2, 3, 4, 5, 6, 7 icons in one column. The last one of them being icon 5A. If we compare this to my hand-drawn diagram, they should be comparable. And icon, again, should no longer be in the first column. 1, 2, 3, 4, 5, 6, 7, correct. And the last one is 5A. Perfect. So far so good. I think now we can start applying the recursive algorithm. But you know what, before that happens, let's just double check if the ordering of positioned icons is correct. Oh, sorry, not positioned icons. The ordering of dependency plane is correct. And I can already see it's not. Sorry. Dependency plane we will need. Okay, so the ordering seems to be fine. I don't think I even have to check those. But the last element is still an empty list like that, which I don't really like. Let's do this. We're still adding this. Something is not right here. But you know what? I think it's fine. We can always figure this out later. In that case, we can figure it out later if it really matters. Are we getting exactly the same result? It could be down to this, but I'm not really sure. All right, what are we getting here? Well, it's almost correct. The first column, definitely right. the second column. Icon 6. This is incorrect. This should be column 3. So it looks like the end, which should be placed here, is placed here for some reason. I have a feeling it has something to do with no, I don't want to speculate. Let's try taking it step by step. Dependency plane is definitely correct. So instead of positioning these icons recursively, let's try to position column by column. The next function here is the we don't want this anymore. let's print that, and also let's print new position icons. We also need to export the prime version of this function. Let's see what it requires. Dependency plane, X, and position icons. I just remember that these are the correct numbers. Let's see the new dependency plane. Can remove this now. Now, so in the second dependency plane, we should see end. Or so we should see the rows. Oh no, sorry. In the second dependency plane, we should see icon 1A and A and B. Question 6, question 9, and 4. Let's see if that is really the case. A1 should stand alone. And it does. Then we should expect 3 icons, and A and B. A is present. B and end. That is correct. In the next row, we should expect 6 and 9. Yep, nothing else, correct. And the next row, just 4. Correct. Now, I wonder what we would be picking. Now, if we go through the list, picking only the first icon from every row, A1, A or 8, 6 or 9 or 4 from every row, well, the algorithm is you know what? We should reverse it first. But before we see how it works, let's do a mental exercise. If we were to take, in its current shape, icons and take them from, and scan them from the bottom to the top, looking for the first icon that's already positioned, 4 would get in because 2 is already done. So in the next iteration, we would only have 4 and its dependence, meaning 4 and 9. But I don't believe that's what we do. Or if we were to attack it from the other side, from top to bottom, we would scan A1. Does it have a dependent that's on the list? No. B, do we have a dependent that's on the list? No. Six. Oh, sorry, 8. Do we have a dependent that's on the row? And here we would say yes. So I think we're just scanning it from the wrong side. Let's see the positioned icons. Starts with the 6. Then A. So it looks like we're taking this section of the tree incorrectly. We scan it from this side. A1. So that will be skipped. Then we take the first item from here. So its parent is already, well, not already on the list of positioned icons. We can go to 6. Yes, and its parent is on the list and goes here. If only we had ordered this collection to be slightly reversed. Let's, just for fun, try to run this function with reversed new dependency plane. Let's see what happens. New positioned icons. Yeah, it only takes 4. So I think if we looked at the diagram, it would look even more incorrect. Where's the preview? Yeah. Which is good. It means that we don't have to reverse. Sorry. All right. But it's good. It means that we don't want to reverse that. We just need to figure out a way of scanning this collection in the right order. I'm just not sure what that order. Well, how to produce that order? If only we had 8 first, it should be picked up. But you know what? One more thing, let's try. Let's see what the original dependency plane was. Was it in the same order? AB8. AB8. So feels like these should also be reversed. Let's see what we get now. Now we still get 6, while we should have gotten just 8. That is not correct. But that's for another day. Yeah. We get A1. Well, and that A, B, and 8. It looks like if this collection was reversed, we would have stood a much better chance. Six is here. Did we not reverse it? Oh, sorry, did we reverse it? Yeah, exactly. We don't want to reverse it. Okay, I think we've gotten close to the solution, but it still requires a bit of work. Instead of going through A1, A6, we should be going A1, 8, and that would be added. And in the next iteration, then we could go A1, A, and then B, and then 6. Oh, sorry, A1, A, and 6. All right, but this is something that we can probably figure out. All right, feels like good progress today. Thanks very much for your attention and for your patience. It looks like I made some good progress today towards resolving the layout problem, layout or remove duplicates problem. During the next session, I would like to finish resolving that problem by properly ordering icons within dependency plane rows. Should be interesting. Thanks very much and have a great weekend.